Hello guys, and welcome to a new episode of The Post-Apocalyptic Inventor. Many decades ago, we were promised a fantastic future that somehow never seems to come. So maybe it's about time that we just build that future ourselves then. And my silly little part in that will be to build a computer desk or some other furniture maybe as well that looks a little bit at least like those awesome consoles we saw all over the place in films like 2001: A Space Odyssey or Alien 1979. And in my last episode, I've shown you this concept drawing here of a first computer console desk that I want to build. And I presented a bunch of LED effects that I want to install in the front panels of this console. And today I'm going to show you a little more of that, in the form of LED matrices, that is. Let's begin then to work on the first matrix, and I start, like so many times before, with a standard perf board, 10 by 16 centimeters, and in this case a number of white, super bright 5mm LEDs, and I put 8 of them in a row just to determine how large the board will have to be. I mark the spot with a pencil, and then I cut along those lines with a knife, only to break off what I don't need manually. And now I drill 4 holes into the 4 corners of the board with my drill press, and then I use a file to grind off the edges. And this is what the board looks like right now. Now I can begin to actually install the 64 LEDs, and I do that row by row. On the back side of the board, I bend over both the anodes and the cathodes to hold the LEDs tightly on the board. They all must be somewhat well oriented so that this looks good, and then I continue to solder the cathodes directly together in rows while bending back the anodes so that they point straight up, and only then I solder them in place. And I add row by row, always connecting the cathodes together in rows until we get to this point here, where now I just use ordinary wire to connect the anodes directly as well. And by directly, I mean without any resistors added to them. And that is what we saw, of course, in the last video, where we had these self-blinking LEDs that already came with 470 ohm resistors, and we drove those LEDs on 12 volts. But this time the LEDs will be multiplexed from a 5-volt rail. And in this context, multiplexing means, among other things, that the LEDs will flash on only for very brief periods of time, so they will not light up continuously for any prolonged amount of time. So I think there will be no danger of them burning through, and I think we don't need resistors using the multiplexer circuit that I've chosen for this. So by connecting all the anodes and all the cathodes together in lines at a 90-degree angle, we effectively get the columns and rows of a matrix. And by choosing any given pair of a row and a column and connecting a current source to that, we can address any of the 64 LEDs in the matrix. And I'm doing just that here with my semiconductor tester. But in order to drive and multiplex the entire matrix and virtually fooling the human eye into seeing complex patterns on the matrix, we need an LED driver and multiplexer. And for that I have chosen the HD16K33 that you can buy in the form of a little backpack board. For example, from Adafruit, but there are also knockoffs out there, of course. And normally backpack means that you would put this directly behind the matrix in order to spare wires. But I want to build something of a development platform here that I can reuse in all kinds of light effects that I'm going to work on in the coming weeks. And that is why the HT16K33 gets its own board, and a rather large one at that. And that is what I'm building here now. A standard perf board is equipped with an improvised socket. The little backpack board is then here inserted, and now a whole number of screw clamps is connected to the board. And now I just take ordinary wire again and I make a connection between all the pins of the little backpack board and these screw clamps. And we're talking here about 16 active high output pins, 8 active low output pins, so 24 all over, and that is enough to control 128 LEDs in a matrix configuration. Then we have a 5-volt pin, ground, and then SDA and SCL, serial data and serial clock, for I2C bus in order to connect this, for example, to a microcontroller. And the next thing we need are 16 wires connecting the matrix to the driver board. And once more, I'm using salvaged power cords. That, by the way, is the reason why you always see me using these rather thick blue, brown, and sometimes even the yellow-green protective earth wires, because I just don't see the point in buying new wires if I have an endless supply of this stuff. So what has happened now? The 16 pins of the matrix are connected to the 8 active low and to 8 of the 16 active high output pins of the driver. The driver is then connected to the lab power supply. It has its own independent 5-volt power supply, but it shares a common ground with the Arduino Uno. And in addition to that common ground, the SDA and SCL lines are connected, giving us I2C control over the HT16K33. And on the Arduino Uno, a demo program was installed just to test the matrix. And by the way, you don't have to be able to program that yourself in the beginning. For getting started, you can find programs like that online already. So what's happening here in this program is that every single LED is addressed in succession. Then the rows are filling up. Then the entire screen is flashing at an increasing frequency. And then at the end, quite briefly though, the lights are dimmed down. The duty cycle of the pulse width modulation is decreased. And then it starts anew by addressing every single LED and so on. It's just a demo program. But you could use this to display characters, patterns, whatever you can do with 64 LEDs and at varying brightness levels. So you can do a lot with that. From this point onwards, it's just a programming matter, no longer a hardware matter. But some of you might still wonder why even go through the hassle of building something like this yourself if, with all that it might be able to do, it still can't do as much as the matrix from the last video, that NeoPixel matrix, and it was only $10 and plug and play, so why even build this? Well, that's really a good question, especially if you're using these really normal run-of-the-mill diodes. But I'm aiming for a more unique look in these prop projects here. It can't have that standard look, and that is why I don't want to use NeoPixel for that. And instead I was looking for, well, rather unusual LEDs so that I could create something of a more whimsical, more unique design. And here come the two matrices that this video is actually about. So my search for a special type of LED really started with the observation that in those classic science fiction movies, many of the blinking lights on all those panels and consoles have a rather large surface area compared to today's typical LEDs, especially those tiny NeoPixel LEDs. So, well, I looked for larger LEDs online, and many of them are very expensive. But then on a German website that sells remaining stock and new old stock items, among other things, I stumbled across these 10mm LEDs for 7 cents a piece. And I ordered 200 of them. So I thought it would be a cool idea to have thick aluminum front panels holding these LEDs directly. And while deciding that, I at the same time turned this into a recycling project, because last year I salvaged a whole bunch of thick aluminum plates from a shelf system, so I got this for free. This is basically scrap. And by just removing a little bit of these sheets, you basically have a good as new rectangle. So I did that, and then I took measurements and marked the spots where holes would be drilled. I punch marked them, and I'm aiming for 100 holes in total here for a 64 LED matrix, and you'll see why in just a minute. I first pre-drilled them with a 6mm drill bit, then with a 10mm drill bit, and then I used a 13mm bit for lack of a better tool in order to remove the swarf and just get more beautiful holes. And here is the first finished half. Now follows the second. And after removing some more excess material from these sheets to make them more symmetrical, I mounted them, as you can see here, on 2 more of these large aluminum sheets, holding it all together. And I think that the outer row of blind holes, basically, where no LEDs will be in, give it an ornamental, more sophisticated look. But that's just a matter of taste. I thought that would be a cool idea to make this look more interesting. And now I started to insert the 10mm LEDs. And after having done that, I again applied MS polymer to all the LEDs, trying not to touch the pins, of course, and not to squeeze it through one of the holes, but just hold the LEDs. And after 2 days of drying, I then cut off all these pins to a rather short length. And here you can see, if you haven't seen it before, that these LEDs have 3 pins. It's one common cathode and then 2 anodes, because these are technically duo LEDs, meaning that there are 2 light emitting diodes within each enclosure, and they did that so that they could evenly light this rather large plastic capsule that is the enclosure of the LED. And we will just connect them in parallel, just as we did before. And we basically treat these duo LEDs as simple LEDs, well, with a higher current input. And I'm connecting all the cathodes and all the anodes together, just like before. And to be honest, I was hoping in this case that we would just not exceed the current limitations of the HT16K33. Next, one of my driver boards was installed on the back side of the panel via an aluminum angle plate. And then, once more, 16 wires were soldered to the matrix and screwed into the clamps of the driver board. And as you can see here, it works just fine. And maybe you're not sure what to think of it now, but just you wait until the end of this video. But I didn't buy 200 of these LEDs to end up only using 64. So of course I made another one with 128 LEDs, and I proceeded in a similar fashion, of course. Took 2 of these old aluminum sheets, took measurements, punch marked them, then again pre-drilled them, drilled them, cleaned the holes, and then glued all of these LEDs in place with MS polymer. But this is where I, at least temporarily, took a different route. I figured that the current of the combined 16 duo LEDs in one line might be too much for the cathode connection or active low pins of the LED driver, so I thought it might be a better idea to connect resistors to each LED and then power the whole thing via external drivers with a 12-volt rail. So I ended up soldering 256 resistors to all of the anodes, and then I built this overcomplicated driver board here around the HT16K33 because I just took parts that I had lying on my shelves, and well, it worked, but it ended up being excessively complicated compared to what I have shown here in this video series before. And well, I figured now that I had several of the driver circuits and that this looked so complicated, let's just try it with the HT16K33 anyway. So I ended up bridging all the resistors, so you can forget everything I showed you just now, and ended up connecting everything directly to the chip. And it worked. So I don't know about you, but I think this is pretty cool. Especially the color contrast between the reddish tones of the effects from last time and the green massive LEDs in these panels. Also, I like how the panels themselves turned out. The material looks very valuable, very rugged. And that is what I'm aiming for. And I can more and more picture how all of this will look like when it's installed in a common enclosure in a computer console. I think this will be really awesome. So what's going to happen next? Now that I've started to get into this whole matrix and multiplexing thing, I'm going to try this with other things, like for example neon bulbs. And I've already ordered a whole bunch of neon bulbs, and I think making a matrix out of these will be really cool. Then I'm working on old oscilloscopes and vector scopes, and I'm trying to generate cool old-fashioned retro-style gaming graphics on these scope screens. Then, of course, the CRT televisions. But another really cool thing that I've started yesterday evening, vacuum fluorescent displays. I already got a source for lots of these old 1980s VFDs. And I think if you install them in the right frame, that could also look really awesome. So there's much more where this came from. And if you like this, then please give this video a like. Follow me on Instagram if you can, where you can get regular updates. And if you want to support this effort here, then please check out my Patreon. See you soon.